Welcome to Rocky Broad Solar, where we encourage you to make the current flow. On today's episode, we're going to be going over the installation and programming of the EG4 Smart Ports inside the GridBoss microgrid interconnect device. So there's a few reasons why you may want to use this. You could use it for load shedding. So if there are some large loads in your home that you either want to shed automatically or shed once your batteries reach a certain state of charge during an outage, you can do so. That's what I'm doing here at my house. I'm having my large loads, my heating and air conditioning, and my electric water heater run all the time when the grid is operating. But when the grid goes down and the batteries reach a 75% state of charge, it's going to go ahead and shed that water heater and shed the heating and air conditioner, so I can save that 75% of my batteries for more important loads during that outage. This can be really critical just for homeowners that want something just a little more seamless and don't want to manually manage their loads. It's also really useful if you're just not home when the power goes out. Who wants to be out at the store or out at work, have a power outage happen, and your heating and air conditioning is just running full speed ahead and you're gone all day long and that thing just drains your batteries down and you come home to a dead battery. I mean, that's no fun for anyone. And so having these smart ports programmed can really prevent issues like that. They also have what they call power shedding. And that's when you have your batteries are charged up and, rather than exporting to the grid, you can dump that power to different loads, such as maybe an EV charger or a cryptocurrency miner or something like that, maybe even a spare water heater. So you could set it depending on depth of discharge. You can also do it during times of day for those of you on time of use. But essentially, large loads that can use excess PV power, you can kind of program those loads to turn on, rather than exporting your energy to the grid. Alright, so a few things to note when you are making a bunch of jumpers inside of a panel. You want to get really picky with your wire management. Get some zip ties, make sure all those wires are secured around the edges where they're not going to be in the way and they're not going to be hitting the bus bar. Also make sure that where your screws go through, they are not going to be jamming into a wire either. Next, make sure you plug any unused holes. So now that I've moved all those breakers out, we would have a bunch of holes in the dead front cover. I prefer to use just spare circuit breakers. Of course, circuit breakers are expensive, but I had a bunch of old ones laying around, so I just slapped those in there to plug the holes so there wasn't an open hole when I put the dead front cover back on. If you're getting value out of today's content, do me a favor, hit the like button, subscribe, press that notification bell, or leave a comment down in the description below. Let's get back into it. Always make sure to label your breakers. One, it's required by code. Two, you don't want to be coming down here a couple years from now going to flip breakers and not knowing what controls what. So just keep your breaker labels always up to date. Make sure that in an emergency or whatever the case may be, you know exactly what breakers are doing what. So you'll see this system is pretty much a whole home backup system now. I have every load in my house backed up except for that electric clothes dryer. Honestly, if I were doing this from the beginning, I wouldn't have this panel at all and I would just go ahead and back up that clothes dryer. But in this case, I didn't have quite enough room in my backup panel, and honestly, I don't really see myself ever needing to run my electric clothes dryer during an outage anyways. But this system is a truly whole home backup system. When I first wired up the house, it was before I bought the solar and batteries, and at that time I wasn't sure that I was going to be able to afford such a substantial battery backup system here, and so I just went ahead and installed a critical loads panel and a non-backed up loads panel, and I was just planning on backing up all my essentials, basically all my single pole breakers. Now that I've got such a big system and I don't really need to connect my generator in there, you know, there's really no need for that panel. Looking back, I could have just used one single panel and saved myself a lot of time and effort there. Okay, so we've got the smart ports installed. Now we are going to program them. I'm going to start with smart port number 4. That is where I have my air handler for my HVAC unit landed. So I'm just kind of going through this for the first time, so you guys are going to join me. So this is a smart load. In my case, what I want to do is when the grid is working, I want my heating and air conditioner to run all the time. So I'm going to go over and enable smart load port 4 grid always on. So that says if the grid's working, it's always on. Alright, so next I want this smart port to shed my heating and air conditioning anytime my batteries are under 75% state of charge during an outage. So I'm going to go over here. I want to do it according to state of charge. I think I'm going to go ahead and enable smart load 4. I'm going to go ahead and use load shedding mode. So we're just going to go ahead and set this to the same settings. We're going to set all these to the same settings. So smart port 2. We're going to do it based on state of charge. Start at 95%. And at 75%, next is going to be Smart Port 3. That is going to be my water heater.
All right, so let's go ahead and test the smart ports here. So right now, you know, it's like noon and the system's been off while I've been doing electrical work. So these batteries are at only a 27% state of charge. If the smart circuits are working as intended, when I simulate a grid outage by hitting my service disconnect outside, at which point the smart circuits should shed the water heater and the heating and air conditioning system. And again, the way I've got them set, if the batteries are over 75% state of charge when the power goes out, it's going to continue running the water heater and heating and air conditioner. At the time that the battery state of charge hits 75%, it's going to go ahead and shed both the water heater and the heating and air conditioning system. And at that point, once it sheds, it's going to wait till that battery state of charge is up to 95% state of charge before it goes ahead and kicks that water heater and heating and air conditioner back on. And my kind of thoughts on that is just essentially once it's 95% state of charge, we've got more than enough power, and then honestly it'll probably be running off of PV power for most of that time anyways. All right, so we can see the water heater is still on. I'm going to go outside and simulate a grid outage. You can see the air conditioner unit is on as well. All right, you'll see that cut the AC unit. That also cut the water heater. Go ahead and flip it back on. All right, so now our batteries are up at a 98% state of charge. I'm going to go outside, hit the service disconnect to simulate a grid outage. And what we should see is that the water heater and air conditioner remain on. Alright, so that's promising. The air conditioning is still running at this time. And so is our water heater. So it seems like the smart ports are acting as they are programmed. If anyone out there is interested in DIY solar, make sure and check out our website at rockybroadsolar.com. Download our free ultimate DIY guide, and it'll give you some good helpful tips and tricks on how to choose the right equipment and how to make sure you pass that final inspection. Also, if you're looking into purchasing any of these products that I've been talking about, again, go ahead down in that description below. Check out our affiliate links, also the discount coupon codes that might give you the ability to save yourself a little bit of money. As always, thank you so much for watching. Until next time, take care. As always, thank you so much for watching. I really appreciate each and every one of you. Till next time, take care.